Hello, Chem 2 students. Mr. Keister here with you again today. This is the video for Thursday, October 22nd, 2020, which is, I believe, our scheduled 44th day of school for the fall semester. Always keep in mind, though, that the dates could change for a variety of reasons, but the lessons and the order that those lessons are presented will remain the same regardless. I think I got that thing memorized now. Don't even have to look at it anymore. So, let's take a look at our agenda, see what the do nows say today. All right, so today you are to pick up your Unit 3-2 review. We must have a test coming soon. Yes, we do. Notice it also says and 3-1, so there's stuff from 3-1 on there as well. I'll talk about that in a little bit. Save a spot for 61. That's coming tomorrow. That will be Lab 3-2, which you'll be doing tomorrow. Yesterday, we picked up the ion formation assignment. We started that assignment yesterday. We looked at metals and transition metals. And today we're going to finish up with nonmetals and metalloids. After today's lesson, you will be able to finish the ion formation assignment from yesterday. And then you are to begin working on your review, all right? That review is technically due tomorrow by the end of class, although I won't collect it until Monday. And we have an exam coming up this Monday. I will post that study list in Canvas. If not later this afternoon, certainly by first thing tomorrow morning. Also, you have an online homework assignment that is also coming due. I opened that up. And it is Unit 3-2, Electron Configuration and Periodic Trends. That is also due this coming Monday, the 26th, I believe it is, by 7:30 a.m. So we got a test coming on Monday, and we have a mastering due on Monday. So just to highlight the agenda here in the coming days, tomorrow we're going to do Lab 3-2 in class. It's quite short. You'll be turning that in before the end of class tomorrow. And then your Unit 3-1 and 3-2 review assignment is also technically due by the end of class. Although, again, I won't be collecting it until Monday on your exam day. But if you have it done tomorrow, which I would highly advise, then you can, of course, check it after you show it to me so you know it's all good and ready to go so that you have it with you to study over the weekend. So Monday then will be our exam, and also your mastering will be due at 7:30 that morning. All right, so let's get back to the notes and finish up with ions. So yesterday we talked about metals and nonmetals and how their ions are formed. They tend to lose, remember, electrons and form positive ions or cations. Remember that nearly all of the metals only have 1 or 2 valence electrons. Group 1A has 1, Group 2A has 2, and all of the D and F block, the intertransition and transition metals, have 2 valence electrons as well. Now, when you get over into the P block, we have metals down towards the bottom of each of those groups, and so they have 3, 4, 5, 6 valence electrons. But again, those metals are at the bottom of the group because as you get farther away from the nucleus, as you go down a group, that Coulombic force and nuclear pull gets weaker. And thus the likelihood of losing electrons, again, becomes more prevalent, which is why that's where the metals are at the bottom of the group, all right, of those groups in the P block. So let's talk about nonmetals and metalloids today. So as you get deeper into the P block of the periodic table, more and more nonmetals appear, all right? Nonmetals start in 3A with boron. And then as you work your way across 4A, 5A, 6A, 7A, 8A, we get more and more nonmetals. In this area of the periodic table, the element's outermost occupied energy level, in particular, their outermost P sublevel, is becoming closer and closer to being full, which is, of course, a desirable electron configuration. Remember, noble gases have the ideal electron configuration, which is why they're so unreactive. So to complete their octet, nonmetals then tend to gain 1 or more electrons and form negative ions. We call those, again, anions, all right? So group 4A, I should say, group 4A nonmetals, then since they have 4 valence electrons and they want how many? They want 8, all right? They would gain 4 valence electrons and form ions with a -4 charge. Again, you can also, of course, write it 4 negative rather than -4. And again, I think mastering prefers that you write 4 negative rather than -4, although both technically are correct. So if we go to the next page here, so here's carbon, which has 6 electrons, 1s2, 2s2, 2p2, all right? So its valence electrons are those 2s and 2p electrons, total of 4. When carbon forms a -4 ion, it's going to gain 4 electrons and fill that 2p orbital, 1s2, 2s2, 2p6, which again gives it the electron configuration of a noble gas. In this case, that would be neon. 5a, having 5 valence electrons, and they want 8, are only going to gain 3 valence electrons and form ions with a charge of -3 or 3 negative. So P, which has, let me look, 15 electrons, would be 1s2, 2s2, 2p6, 3s2, 3p3. Yep, 3p3. There are those 5 valence electrons, the 3s2 and the 3p3. And forming the -3 ion, or the 3 negative ion, it's going to gain 3 electrons and fill that 3p orbital. 1s2, 2s2, 2p6, 3s2, 3p6. Again, that filled p orbital is much more desirable, and so the p -3 ion is certainly more stable than the neutral p atom. Okay. 6a nonmetals with 6 valence electrons only want to gain 2 valence electrons to get to 8. Form ions with a charge of -2 or 2 negative. Oxygen has 8 electrons, 1s2, 2s2, 2p4. There are its 6 valence electrons, the 2s and the 2p. The O-2 ion, or O2 minus, is picked up those 2 electrons, 1s2, 2s2, 2p6. Okay. 7a, getting close now, only want to gain 1 valence electron. They're only one shy of an octet, and form ions with a charge of -1 or simply just minus. Okay. So chlorine has 17. Yep, 17. 1s2, 2s2, 2p6, 3s2, 3p5. And the chloride ion, Cl-1, or just Cl-, picks up an 18th electron and fills that 3p orbital, 3p6. Okay? So nonmetals gain electrons to get to their octet. They want to get to 8 and form negative ions, which we call, again, anions. Notice I called O-2 oxide and Cl-1 chloride. You might remember from Chem 1 that the negative ion's name is not the same as the neutral nonmetal atom's name. Instead, changes to an IDE ending. That is coming soon. All right. So anyway, elements near the stair-step line. All right. So basically, metalloids and those near the metalloid area. So elements that border the stair-step line on the right side of the periodic table, over there in the P block. Whether they are technically metals, nonmetals, or metalloids, can do several different things in regard to ion formation. Let me star this. It all depends on the amount of energy involved. How much energy they require to either lose electrons and form a positive ion or gain electrons and form a negative ion, and how much energy another atom requires in losing or gaining electrons to react with them. Whichever is the least amount of energy, that's what happens. All right, that's what happens. So it depends on the individual atoms involved. So in group 4A, let's look at 4A. So the stair-step line in 4A runs underneath silicon and germanium, And so silicon and germanium are both technically metalloids. Now, we'll talk about what's more likely to happen here in just a second. So let's look at germanium, right? Germanium's number 32. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, or p2, I believe. Looks like it's in the 4p2 slot, 2, 4, 10, 12, 18, 20, 30, 32. Yep, that's it. All right, so we have a multitude here of ions that germanium can form. First one is the -4 ion. So if it forms a -4 ion, that means it has to gain 4 electrons, which would put it up to 36, of course. And where are those 4 going to go? Well, it's going to fill this 4p. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. All right, fills the 4p. Germanium can also form a +4 ion. Now, for germanium atom, which is up here, the neutral atom forms a +4 ion, it's going to lose 4 electrons. Well, where are those 4 electrons coming from? Well, they're going to come from its outermost energy level, which is the electrons that are least tightly held. So those would be the 4 electrons that are found in the 4s and the 4p orbitals, 2 in the 4s and 2 in the 4p. So if we remove those 4 from the neutral atom, which takes us from 32 electrons down to 28, this first part here is the same, 3s2, 3p6, but now the 4s2 are out, so we go 3d10, and the 4p2 are out as well. So in other words, all the valence electrons are out. All right. In some cases, germanium can form a +2 ion, which means the neutral atom has only lost 2 electrons. Now it has 4 valence electrons, 4s2, 4p2, but if it only loses 2, which 2 are it going to lose? Well, it's going to lose its higher energy electrons, which would be the 4p electrons. Keep in mind, too, that 4s orbital is full. If it's full, it's probably not coming out of there. It's going to come out of the higher energy electrons, those p ones, and that orbital is not full yet. And so we're only going to remove the 4p2. So we're taking from our original 32 only down to 30. So 1s2, 2s2, 2p6, 3s2, 3p6. The 4s2 are back in. The 3d10 are still there, but the 4p2 are out. So only those outermost p electrons are out. All right, because they're a higher energy than the S ones. Okay, now take a look at where germanium is on the periodic table. As I look over there at the one on the wall, germanium is located, again, it borders the stair-step line. It's a metalloid, but look on what side it is. Look on what side it is. It's underneath the stair-step line, which means it's to the left. On the left side, it's on the metal side of the stair-step line. All right. Having said that, which of the 3 ions is probably the most likely? If it's on the metal side, then it appears it would be a little more likely to lose electrons rather than gain them. And so having said that, my prediction would be that the 2 positive ions would be more likely, and in particular, probably the +4 ion, since that clears out its valence orbitals. Okay. But there again, it's going to depend on what other atom germanium is reacting with and how badly that atom wants to either lose or gain electrons itself. Whatever the energy involved is there, whatever's the most energetically sensical thing to do in regards to lowest energy required, that's what's going to happen. So all three of these ions are possible, but it's just going to depend on which other atom germanium is reacting with and what that atom's electron situation is. Okay? 5A. So let's look at antimony. So antimony, again, is underneath the stair-step line, which puts it on the metal side. So again, even though it's a metalloid, it's probably, in all likelihood, normally going to more act like a metal than it is a non-metal. So antimony is number 51, I think. Yes. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p3 is its position. Let me double check that. 2, 4, 10, 12, 18, 20, 30, 36, 38, 48, 51. Yes. All right. So the antimony forms a -3 ion. It's going to gain 3 electrons, which means it's going to fill that 5p orbital. So 5p6. Going to do a little cheating here. Can't do that on your homework, but you can do it here on your notes, so we don't have to rewrite all that. We'll just put the last 3 in there. So 5s2, 4d10, 5p6. That 5p then is full. All right? If antimony forms a +5 ion, that means that it's going to lose all 5 of its valence electrons, which are the 4s2, or the 5s2 and the 5p3. So our neutral atom has 51 electrons. A +5 ion would then have 46. And again, I will leave the 4p6 here. The 5s2 is out. The 4d10 are still in, and the 5p3 are out. The rest, of course, is the same. And then if we just lose 3 electrons, it would just be those higher energy electrons in the 5th energy level, which would be the 5p3. So now we have just lost 3, so that takes us from the original 51 down to 48. And so, again, 4p6 is still there. The 5s2s are back in, and the 4010s are still there. Only the 5p3s are out. So this is a very similar situation to germanium. That gets nearly the same. But since we're in 5a, the electrons lost or gained is a little bit different, off by 1, actually. All right? And again, with germanium lying on the metal side of the stair-step line, I would say that these positive ions, in particular the +5, is probably more likely, all right? But, again, depending on the other atom antimony is reacting with, it could be any of the 3, actually, okay? All right, 6a, we go on to, getting close to the end here, folks. All right, so 6a, we're looking at selenium, which is number 34. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p4. 4, 10, 12, 18, 20, 30, 34. Yep. All right. Take a look at your periodic table and see where selenium is. It is actually 1 slot above where the stair-step line goes through in 6a. And so, although it's close to the metalloid area, it is technically a non-metal. All right. It's really on the borderline there, kind of close. So, being on the non-metal side, I would think that in all likelihood, its most common ion would be forming a negative ion, which is what nonmetals do, which would be the -2 ion, which would then fill that 4p orbital. So let's just go 4s2, 3d10, 4p6. Leave the rest the same. Again, don't do that on your homework, please. Just try to save a little time here. So now we filled that 4p orbital. If selenium forms a +6 ion, then its neutral atom will have lost all 6 of its valence electrons, which takes it from 34 down to 28. See, the 3p6 is still there, the 4s2 is out, 3d10 there, 4p's are out, the rest is the same. So we clear out that valence, those two valence orbitals, all right? And then selenium plus 4 is only going to lose 4 electrons, which would be its highest energy valence electrons, which are the 4p4. So that takes us from 34 down to 30. So 3p6. So 4s2 is back in, 3d10 still there, and only the 4p4s are out. I hope you're seeing a pattern develop here between these, the ones we've just looked at, because it's very, very similar in each and every case. All right. Again, my prediction here is that selenium most likely is going to form a -2 ion, given its location in 4a. But again, that could vary. Just depends on the other atoms selenium might be reacting with. And then finally, 7a, iodine. So iodine's number 53. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p5, I believe. 2, 3, 4, 5. Yes, 5p5. Let me double check. 2, 4, 10, 12, 18, 20, 30, 36, 38, 48, 53. Yeah. All right. So I-1. Look where iodine is. Again, it's close to the stair-step line, but it's technically not a metalloid. So in all likelihood, its most common ion, of course, would be that of a nonmetal in that group, which again, we talked about earlier, would be gaining 1 electron to fill that p orbital. And so that would be its -1 ion. So that would, let's just go 4p6, 5s2, 4d10, 5p6. That would fill its p orbital. Very highly likely there. Iodine could form a +7 ion. It doesn't very often, I can tell you that, but it will occasionally, something that really wants to gain electrons. If it loses 7 electrons, it would clear out all of its valence electrons, which is 7. So we'll take off 7 from 53, 46. And let's see, we still have our 4p6, our 5s2 are out, our 4d10 are still there, and our 5p5s are out as well. So all 7 of those valence electrons would be out. If iodine just forms a +5 ion, which it could, looking back at the neutral atom, that would just pull its highest energy valence electrons out, which would be the 5p5s. So that would take us from 53 down to 48. Of course, 4p6 would still be there. The 5s2s now are back in, 4010, and only the 5p5s would be removed. Okay? So when you're over there in that stair-step line area, you could have multiple things going on. Again, it's going to depend. Look at the location in particular. All right, look how close it is to the stair-step line and on what side of the stair-step line it's on. That would probably help me predict help you predict which of the ion possibilities is most likely. All right, more times than not. But there again, depending on what other atom that particular atom is reacting with, again, based on the energy required to either lose or gain electrons when looking at both atoms involved, could go either way. Okay, could go either way. So I think that finishes up Unit 3.2 on periodic trends in the periodic table. So you were to finish the assignment you started yesterday. That is due tomorrow. Get working on your review. All right, that technically is due by the end of class tomorrow, although it won't be collected until Monday when you have your exam. Again, I will hopefully have that study list posted yet today. I think I will, probably later this afternoon. And then if not, it'll sure be up there first thing in the morning. Tomorrow we'll be doing Lab 3.2, which shouldn't take that awfully long. You'll be turning that in tomorrow before the end of the period, and with whatever time you have left, you can continue to work on your 3.2 and 3.1 review. There's 3.1 stuff on there too. Or hopefully if you have it already done, then you can check it right away before then. But either way, hopefully if you have it done before the end of the period, you can check it before you leave, so you got it with you all over the weekend, all set and ready to go. Mastering due Monday morning as well, 7:30. This one's not too terribly long and not too terribly difficult, so I don't think that should give you too many issues. So until next time, this is Mr. Keister signing off. Take care, everyone. Stay safe. Keep working hard. Stay focused. And I will catch you next time. So long, everyone.